Hello everyone, this is group 3, Yashwanth and Harsha, and this is the demonstration of our art gallery problem solver. On the left hand side, as you can see, there is a canvas where the polygon will be displayed at each step of the algorithm. And on the right hand side, we have a controls panel which involves the buttons to move through the algorithm. And there is also an information pane which will guide the user through the steps of the algorithm and also display the status of the algorithm. So first, let's begin with a simple polygon case. In this, we provide three methods of taking input of polygon. First is the most flexible one, which is click to create. In this, the user just has to click on the canvas to create the polygon, and there is also the button to undo the last point or even clear all points. So let me show you an example. Uh, at the end, you just have to double click on it or click on this complete button to to create the polygon. The second method is using manual coordinates. In this, you have to provide the coordinates of the points in this format, as you can see. So for an example, if I provide points like this, it will create the polygon. And the third type is random generation. In this, the user can provide the number of vertices, like I have provided 10 here, and if I click on random, it will create random polygon on each click. And in this, we can also obtain a particular type of polygon, which is star polygon. Successfully created the polygon. Now here you will be able to see a save as PNG button which will persist at every stage of the algorithm. This button helps the user to capture the canvas picture at any stage of the algorithm. For example, if I click, as you can see, we can save the image in our local system. Now let's move to the next step, which is the sweep line. Here you can see we have a sweep line pane. This pane first involves a legend which shows what is the color of each type of vertex, and also in which color the diagonals and sweep line will be there. And in the algorithm status, we will be able to see how many diagonals have been created so far, what are the active edges, what is the helper vertices for each edge, etc., and other information, other useful information. And if we initialize the sweep line algorithm by clicking on start sweep line algorithm button, and now as you can see, the sweep line algorithm has started, and the current vertex which is getting visited by the sweep line has been highlighted in this green color near my cursor, and also the type of the vertex has been shown here along with its number. So if we move, as you can see, at each vertex, uh, it is showing the type of the vertex and handling it according to the sweep line algorithm. As you can see, at each step, the helper edges and the active edges are also being updated, and also in the information pane, the total number of diagonals and monotone pieces is also updated. The sweep line has been done for this polygon, but we have given user more flexibility as to which elements of the sweep line they want to see. For example, if I toggle this button and I start the sweep line algorithm again, here you can see the sweep line is not being shown here. So he or she can toggle any of these buttons as per her requirement. And as you can see, the save as PNG button is persisting at each stage, and we can obtain the picture at any time, at any moment. Now let's go to the next step, which is triangulating monotone pieces. So here, as you can see, we obtained four monotone pieces for this particular polygon. Uh, Now by clicking on next piece, it will go to the next piece, and it will perform the triangulation of each monotone partition obtained by clicking on next step. So as you can see, the diagonals have been created, and if I click on next piece, it goes to the next monotone piece in the order. And you can also see that the information pane is updating with each button click to help the user through the algorithm. Finally, we have triangulated all the monotone partitions. As you can see, this is the final output of the triangulation. Done with the triangulation of our polygon. Now to build the corresponding dual graph, we need to click on this build dual graph button. And as you can see, we have created a dual graph node for each triangle, and the adjacent triangles have been connected using an edge in the dual graph. Now to perform 3 coloring, you have to click on this button, and as you can see, we have obtained the colors for each of the vertex such that no two adjacent vertex have the same color. Finally, we are done with 3 coloring of our polygon vertices. Now we have provided user with the feature to obtain the visibility polygon of each vertex. For that, the user has to click on this button, and for any particular vertex, he can choose the vertex. For example, if vertex 3, this is the visibility polygon. As you can see, V3 is able to see the entire shaded region, which is shaded in red. Now, to obtain the minimum vertex guards, there are two options which I have provided the user. One is the unweighted case, and another one is the weighted case. So let's first visit the unweighted case. In this, each vertex has an equal weight, and the main motive of this problem is to reduce the number of guards. On clicking this button, as you can see, the algorithm highlights only those vertices which are the final guards. And here in the information pane, we can also see uh, for each color how many vertices are there and what are the final guard positions. After seeing the basic unweighted art gallery problem case, let us see the weighted art gallery problem. Now, the main motive of this weighted case is that we can give weight or cost to each vertex. That is, if higher the cost or weight of a vertex, less is its probability of getting selected. That is the main objective of this problem, is to uh, lessen the overall cost of the chosen vertices. So here, as you can see, we can provide weights, any weight to any vertex, and there are also some predefined weight distributions like random, gradient, etc. And at the end, we have to just click on find minimum guards to obtain the minimum guard placement corresponding to that weight distribution. Done with the simple polygon case. Now let's see polygon with holes case. Now here you can see we have provided the same three options to create the outer polygon. So for example, if I create the outer boundary like this and click it, it will be created. Now we can for adding holes also, we have provided the same three options as you can see here. So let me create an example hole. And here we have also provided hole management, and the user can use these two buttons to either clear all holes or remove the selected hole. Now if we click finish and proceed, we have completed our polygon creation. Now if for moving to the next stage, we have the user has to click on this button. Now as you can see, on clicking the sweep line button, it has pre-processed the polygon and constructed a bridge by creating duplicate vertices here. Now from this onwards, the processing will be exactly same like a simple polygon. As you can see, the monotone partitioning has been completed, and we obtained two pieces. Now we are done with the triangulation. This constructed the dual graph. This performed the three coloring as before, and there are similar options as in the simple polygon case. Here also we have provided weighted and unweighted. So if we want to obtain in unweighted case the minimum number of guards, it will we have to click on this, and here we have provided highlighted the minimum guards in polygon with holes case also. Thank you. This was the demonstration of our AGP solver.